Hi everyone, welcome to week 7. This week we are going to solve log equations. There's only one screencast this week. You are watching it right now. After you finish watching this wonderful screencast, there's a practice worksheet linked in the module along with its answer key. So do the worksheet, check your work, and if you have any questions, please send me an email. On Wednesday, I was thinking we'd do a Google Meet to say goodbye to the seniors. Stay tuned, and your benchmark is due by 7 p.m. on Friday. Let's go. Here are some suggested steps for solving log equations. When you look at the equation, the first thing that you want to do is see if you can apply the power rule. So if you see any coefficients, you want to use that power rule and make that coefficient become the exponent on whatever you're taking log of. So it's always the first thing. Then your goal is to condense. There's two types of log equations. One type is where all of the terms are logs. If that's the case, then your goal is to condense both sides of the equal sign so that you have a log equal to a log. Then you can use your cancellation rule, cross out the logs, and set what you're taking the log of equal to what you're taking the log of on the other side. You'll see it. We're going to do examples. The other type, though, is if you have a non-log term. So like just a number, a term that doesn't have the letters log. If that's the case, your goal is to condense it down to one log and then rewrite your log equation as an exponential. So that's the game plan. We'll see both types. We're going to do 5 examples today. And one thing, no matter what type it is, you always have to check your answers to see if they are extraneous. So how you test is whatever you think x is, you have to take it, plug it back in for x, and you cannot take the log of a negative number. So if you plug in x and it ends up that you're taking the log of a negative number, that solution is extraneous and you reject it. Oh, hold on. It keeps wanting to skip number 1, and I don't know why. Look what I learned how to do this week. Pretty cool. All right, number 1, let's do it. Here's our equation. So I got to figure out what type is it. Are they all logs or is there a non-log? Log, log, log. So it is this type. All the terms are logs. My game plan is to condense both sides so that I only have one log on each side. So this is all set. This I need to condense. You apply that power rule. So the 3 becomes the power on the 2. And then you'll use the power rule again, and this 2 will fly up and become the exponent on the 4, just like you see there. You can simplify. And now when I look at these 2 logs, I am adding the 2 logs. So that tells me I can use my product property, write the word log once, and multiply what I'm taking the log of. So I'll multiply 8 times 16. Now, once you have log equal to a log, and they're the same base, you can cross out the logs and set x equal to 128. Solve for x, but x is already by itself, so you don't need to do anything there. And the very last step is to check your solution. So when I plug 128 back in for x, I'm taking the log of a positive number, so things are good. Number 2, here's my equation. I've got to first ask myself what type it is. So I've got log, log, log. So again, it's the same type where all the terms are logs. I'm going to use my power rule first. So this 2 is going to fly up and become the exponent on the x, like you see there. And then my goal is to condense. I have 1 log here, so that is good. Over here, I need to condense. If you're subtracting 2 logs, you're going to use your quotient rule. You're going to write the word log once and you're going to write x squared over 2. Now you have a log equal to a log. Cross out the logs. Set what you're taking the log of equal to one another. Solve your equation. I'm going to get rid of that fraction. So I'm going to multiply every term by 2. And then I look at it and I have a quadratic, so I'm going to set it equal to 0. So I'm going to subtract 6x, and I'm also going to subtract 16. I'm going to factor my quadratic, and then I'm going to set each factor equal to 0 and solve for x. Last but not least, I need to check those solutions. If I take 8 and plug it back in, everywhere I see an x, everything works out. However, when I take this -2, right there, when I substitute that in, I cannot take the log of a negative number. So I need to reject this. This is extraneous. My only answer is x equals 8. Number 3, first thing I do, ask myself, what type of log equation do I have? So I've got log, log. This is a non-log term. That means that it is this type of log equation, and these are the steps that I should follow. So first thing, I need to make sure that all the logs are on one side. That is true. Second thing is condense to a single log. So I am subtracting, so I'm going to use my quotient rule. I'm going to write the word log once and write x plus 3 over x minus 1. Now for this log, you don't see a base, but if you recall from last week, when you see a logarithm with no base written, the base is assumed to be 10. So I'm going to rewrite it as an exponential. 10 to the first power, set it equal to what you're taking the log of. So you're just switching forms from log form to exponential. Here's your equation. I'm going to solve it by multiplying both sides by x minus 1. This will cancel on the right-hand side. I can distribute the 10, and I have a linear equation. So I'm going to group all the x's on one side, all the numbers on the other. I'll subtract x from both sides, add 10 to both sides, divide by 9, and last, check my solution. When I plug 13/9 in for x, everything works out. You end up taking the log of a positive number, so that is a valid solution. Number 4, first thing, what type of equation am I dealing with? Log, log, I got a non-log right here. So this is my plan of attack. Are all the logs on one side? Yes. Condense the logs down. I look to see whether I have to use my product rule or my quotient. Because I see the addition symbol, that tells me that I need to use my product rule. I'm going to write the word log once. I'm going to multiply what I'm taking the log of. And now my last step will be to rewrite this log equation as an exponential. So scoop and loop. 7 to the first power, set it equal to what you're taking the log of. I can multiply my binomials here. I have a quadratic, so I want to set it equal to 0 by subtracting 7 from both sides. I'm going to factor my quadratic. I'm going to set each factor equal to 0 and solve for x. And then my last step, don't forget this, is to check my solutions. When I plug 6 in for x, they work in both cases of the logs that I plug it in. However, when I plug -2 in for x, -2 plus 1, that gives me -1, and I cannot take the log of a negative number. So once you find out that it doesn't work, you can reject it. It's extraneous. The only solution would be x equals 6. One thing to note is if both of these answers did not work, your answer would be no solution, just so you know. The last example that we'll do today, again, take a look at what type it is. I've got a log, I've got a non-log, and then a log term. So because I have that non-log term, here are the steps that I'm going to follow. I need to first make sure all the logs are on one side. So I have some work to do on this. I need to add log base 5 of x and bring it to the other side. Then I'm going to condense. So because there's addition, I'm going to use my product property, write the word log once, multiply what you're taking the log of. My last step is to rewrite this log equation as an exponential equation. So 5 to the first power, set it equal to what you're taking the log of. And I'll distribute the x. I have a quadratic, so I'll set it equal to 0 by subtracting 5. I'll factor my quadratic, set each factor equal to 0, and get x by itself. My last step is to check my solutions. So I will plug 5 in. It works out. I'll plug -1 in. -1 minus 4 would give me -5. So I need to reject this because I cannot take the log of a negative number. The only solution for this would be x equals 5. Woo, so that's it. That's a wrap. So like I said at the beginning, there's that practice worksheet on the module. There's also the answer key so you can check your work and you can see all the work done out to make sure that you're doing it correctly. And yeah, have a wonderful day. Bye, guys.